In today's video, I'm going to quickly go through vectors. Well, not quickly. I'll probably make two videos just to kind of cover the basics, and then after that, we'll do some past paper examples. So vectors, if you Google it, you'll see it's something that has a direction and a magnitude. And what does that mean in math? Well, if I have a Cartesian plane, and let's say the origin is point A, so I have the origin. And then there's a point B. I don't know, let's just make the point B there. Point B. If I were to draw a line, let's say I drew a line. Well, let's get a better pen. If I go from A to B, you would agree that I'm going a certain distance and I'm going in a certain direction. Obviously, it's more to do with physics, and that's more applied, but for IGs, we're going to mostly focus on the notation and what it means. So let's say A is my starting point, as B is my ending point. If I'm going from A to B, there's a certain direction. I'm going, I don't know, that's like 60 degrees maybe, and I'm going upwards in that direction, and then I'm also going a certain direction, a certain distance. If I told you you want to go the same distance but in another direction, you'll not get to that point. So there's certain ways how we write vectors. So if I'm going from A to B, the easiest way to write it is having this AB with a little arrow. So if you see that arrow, you know that's the direction from A to B. It is not the same as B to A. Okay, so A to B is that direction, and it's important that a vector will have this little arrow in there saying that we're going from A to B, and if I'm going in the opposite direction, that's not the same thing. There's another way that we write it. If you see in your IG exam, it'll be an A that's bold printed. Let me see if I can find an example here quick. Okay, this isn't an A, but you can see there it's a Q and a P, and they're printed in bold. But you and I, we can't write in bold. So if I wanted to write AB, or I wanted to give it a different name, maybe A, then I'll do this little squiggly line under it. So A squiggly line. Now, I know I'm like talking a lot, but in a while it'll make a little bit more sense. If I'm going from A to B, B's coordinates, let me just write B's coordinates there. B is the point on the x-axis 1, and on the y-axis it's 2. So B is basically the point 1, 2. If I'm going from A to B, I'm going 1 unit positive in the x direction, or x is positive 1 unit, and I'm going 2 in the y. So there's a way in which we write these vectors. So this is obviously a way we write it and that, but when we want to kind of show how we're writing vectors, we have this thing we called column notation, column vector notation, and we have these big brackets, and the top part will tell me how much I'm moving in the x direction. Sorry, there we go. Phone made a little noise. In this case, we're going 1 unit positive in that direction, and we're going 2 units up. It can be confusing because when we do straight lines, we're doing change in y over the change in x. So we're kind of used to seeing the y value at the top and the x value at the bottom. But with vectors, the top value is the x and the bottom value is the y. And if I wanted to, let's say I went in a different direction, let's say I started at this point and I went in that direction, and this is my vector. Let's say this is called C, and that is D. And I'll give it a little name. Let's make it B, little thing below it, B. So B is in the direction from C to D. The direction is very important here. From C to D, how many units did I go or move in the X direction? Well, I moved 2 backwards. So that's going to be -2, 1, 2. And then I move 2 down. So that's -2 down. So this is just kind of ways how I write these vectors. Now, let's say I moved from A to B, and then I moved again from B somewhere around to there, that point over there. And let's call that point Q. Sorry, I already used C, so I'm just going to kind of take all this away quick. So, and I'm going to use C. So A, we saw already that was 1 unit forward and 2 units up. And I know C is going to be 1, 2, 3 units forward and 1 unit up. Okay. But I can also just go from A to Q directly. A all the way to Q. So if I wanted to do A to Q, that would be, let's say 1, 2, 3, 4 units forward and 1, 2, 3 units up. And obviously I have to show my direction. Sorry, I didn't show the direction in these two. So there's kind of 2 paths. I can go A to B and B to Q, and then I'll get there. But the short and the fastest route would just be from A to Q. And I kind of worked that out. But what's really interesting is these vectors, I can add them up. Basically, if I took A, which is this part, the 1, 2, and I added it to the C part, which is 3, 1, look what happens. 1 plus 3 is 4, and 2 plus 1 is 3. And that is exactly the same as that 4 and that 3. So we see that vectors can kind of be added, and there can be different routes that we walk to get from the one point to the other point. One important thing to note is that we don't really care where we start and where we finish. So they might ask you, hey, write this vector D, and we're going to go -2 and 3. Write this somewhere on a plane. So it doesn't matter where you start. If we start at the center or the origin, then we call it a position vector. So position vectors would always start kind of at the origin. But if they just told you, hey, draw this vector somewhere on this plane, you can decide where you want to start. So let's say I start there. I'm going 2 backwards. So let's say 1, 2, and then 3 up, 1, 2, 3. So basically this will be the vector D. It doesn't matter where, as long as I went 2 back and 3. I could have started there and went 2 back and 3 up and drew it there. So that's just their notation. I can also add and multiply and do kinds of things with this. So for example, if I took A and B and I extended it by the same distance, let's say A to B, and I went all the way to, I'm just making up weird. Let's make this X. If I go from A to B and I double it, I can see that, let's write A plus, let's give this one, sorry for all these weird D, let's make it E. A plus E is going to be, A is 1, 2, 1, it's not fractions, sorry, 1, 2, plus E is also 1, 2, because they're the same thing. And we can just add these things, and it's going to give me 2, 4. And I can see here, if I just go from A to X, it's going to be 2 forward and 1, 2, 3, 4 up. So I could also write this as 2 times A, or 2 times 1, 2, because 2 times 1 is 2 and 2 times 2 is 4. So there's a lot of calculations that we can do when we're just multiplying with numbers. They call these numbers scalars, So we can multiply and add and subtract and do all kinds of things. So we'll look at the past paper examples, but this is just kind of to get a rough idea of what the notation is. That this is the movement in the x-axis or x direction, either forward or backward, left or right. And this is the movement in the y direction, so either up and down. So yeah, in the next video, I'm going to go into the question. Oh, let me just use an example here of some past papers. I have some printed here. Take a look. So these are kind of questions that has to do with this type of notation. And then these questions, this is kind of what we want to get into, these types of shape things with the vectors and breaking it up. So in the next video, I'm going to go into what this means.